just tell you a little bit about David. David's worked with the Oracle database since 1989 and with PeopleSoft ERP applications since 1996, specializing in system performance tuning. He works as an independent consultant, and David is a regular presenter at Oracle and PeopleSoft conferences. He's the author of PeopleSoft for the Oracle DBA and blogs about PeopleSoft and Oracle. David is also an Oracle ACE director and a proud member of the Oak Table, a very distinguished group of Oracle individuals and technically savvy people. And he's also the author of PeopleSoft for the Oracle DBA, published by A-Press. Again, thank you, Viscosity and David, and enjoy the webinar, everybody. I'll hand it over to David.
Okay, thank you very much for the introduction, and hello everybody. So today's session I'm going to talk about active session history. It's been around for a while, but I'm going to encourage you to dig into the data for yourself and understand what data is collected there so you can investigate it yourself, rather than just use the tools that are available to help you do that. I think there's some real value in that. So I specialize in performance tuning, and you can write about the kind of thing that I do on my website and on my blog. A lot of it's about PeopleSoft, a lot of it isn't about PeopleSoft, and while today I will be illustrating some examples with PeopleSoft based cases, they apply generally. There is really only one question in performance tuning, and it's how much time did I spend doing what? That is the question you have to keep asking almost relentlessly, and you follow the time. And then you say, what can I do about it? And nearly all the time, the answer is to stop doing whatever it was that you are doing. And that's how you address a performance problem. Active session history is a way of answering the question of what is the database doing? Bear in mind always that there may be time spent elsewhere, but active session history will let you dig into DB time. So I'm going to look today at the fundamentals of active session history. What is it? How does it work under the covers? I'm going to talk a little bit about the mathematical basis for it. There is just a little bit of maths that you have to appreciate. Before there was active session history, that we all used trace. You know, I spent 15 years before Ash appeared tracing everything inside. So I think it's worth comparing and contrasting Ash and trace. And I will talk about probably the most important single thing that a developer can do, which is to instrument code. And then I'm going to show you some examples curated from real life, which is where I have been digging into the data. So here we go. The exact details are going to depend upon the application. How you dig into the data also depends on the application. So simply taking my scripts and applying them to your problem may not be ideal. So I want to get across the principles that you have to follow and the techniques. But it's always the same thing. Look for the thing that consumes the most time and then go off and address that. Ash will help you identify what it is you want to address. And you'll profile by DB time. You might profile a SQL ID or a plan hash value, or you might do blocking lock analysis. But the question's always the same. How much time did I spend doing what? So let's talk about the fundamentals of how Ash works. So Ash was principally architected by Graham Wood at Oracle. He was the principal architect. Graham no longer works for Oracle. He's retired to go motorcycling, but he's left behind a number of presentations and YouTube videos which explain how it works. And I've lovingly ripped off some parts of his presentations for this. It's well worth a couple of hours looking at this. The other person there is John Berezhnowitz. He's now back with Oracle, and he's responsible for a lot of the mathematical rigor in the product, and their names appear on the patents that Oracle filed for active session history. Again, John has also done some presentations last year, which are well worth the watching. Key thing to get across is active session history is a sampling technology. That technology is built into the database. It's built into the database. That technology is built into the database. So it's always on, and it's a low overhead, and therefore it works if the system is ever overloaded. And it was designed to be so. There's no locking, there's no latching involved. It simply reads memory registers. And then those samples are collected and presented back to the user, and they're also 1 in 10 of them persisted into the AWR repository. Let's talk a little bit about process states and just what's being measured. So we might have a process that lasted an amount of time, and during that process it may do a number of things. So it might query the database, it'll fetch data, it may then do an update, and finally it'll commit. And each of those are calls made from the client process. So the database is active during those calls, and the client process is waiting for those calls to return. And it's those client calls in red, they're the things which are measured by active session history. So active session history samples regularly. Those vertical lines might be the samples. And you might have, say, this client process, it lasted a little over 10 seconds, so it might attract 10 samples. And here, the database calls, where they intersect with a sample, a row is collected in active session history, and the presence of that row means there is a second of database time. So you've got 6 seconds of database time, but that's not the total response time that the user sees. So bear in mind that there's 4.5 seconds that are outside the database, and that can be significant. After all, if you got those 6 seconds down to 0, which of course is impossible, you'd still be left with 4.5 seconds of database time, and there's nothing the DBA could do about it. So understand what ASH is measuring. It's only measuring database time. So let's draw that kind of diagram again. Here I've got 3 sessions, and they all consumed 4.5 seconds of database time. And where they intersect with the sample, Oracle will collect a sample. So this one, it intersected with 5 sampling events. So we had 5 ASH samples, and we say that's 5 seconds of database time in terms of ASH. This one only collected 4. So it's not an exact measurement of what actually happened. It's an estimate because it's a statistical sampling. And here, where we've got the 4.5 seconds broken into 9 little pieces, well, that's a sample, that's a sample. That one missed, so we don't count. Miss, 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 just missed, hit. So that one was 5 seconds. So you get approximately the right amount of database time capped from ASH. And the larger the sample size, the smaller the error. So let's just add a few more sessions just to make it more interesting, and a few more samples. And there they go. So you can see how much database time each process took. You might also aggregate the ASH samples for a particular point in time. And you can say that any instant in time, there were this many active sessions. And you sometimes hear people talk about the average active sessions in a database as the level of activity. And I could draw a bar chart of that activity, and I've now got a view of how active the database is across those sessions. And in fact, instead of drawing it as a block diagram, if I just join the points up, I now start to get a graph that's far more like the charts you see in most of the performance tools. And in fact, that blue area that you see now is exactly the same size as the blue area that's just disappeared. It is an approximation, and I've got 26 samples here, so I'll talk about 26 seconds of database time. If you actually add up the amount of time on these sessions, there's a discrepancy. It was actually 24 because of the way they fell across the samples. Don't get too worried about this, because the key thing is which is the things that burnt the most time. What is that mathematical basis then for ASH? This is John Brezhnevich's work, and he says that the rate of change of database time, the rate at which you accumulate database time, is equal to the number of active sessions. And therefore, if you integrate the number of active sessions across a period of time, then that's the total database time in that time window. That's the calculus of ASH. So when it comes to actually doing the math yourself, what do you have to do? Well, the database time is approximately equal to the interval between the ASH samples multiplied by the number of samples, where S is the set of samples. Or if you prefer, it's approximately equal to the interval between the samples multiplied by the number of rows in your ASH data. It is as simple as that. And that is going to be 1 second if you've taken it from the in-memory ASH repository. And because only 1 in 10 samples is persisted to AWR, that's going to be 10 seconds if you're getting it out of the AWR repository. More later. So how does ASH work? What is the mechanism that's going to deliver this data to us? So when you connect to the database, you create a session. Inside the SGA, there is a session state object. It's a piece of memory, and it's exposed to us through the dynamic performance views. In this case, $V session and $V session weight. The $V views, generally, they are just views of memory in the SGA. And some people have written their own shared memory attached programs, which will expose exactly the same data. The contents of these views are instantaneous. There's no read consistency and there's no latching. And you can get inconsistent data if the data is halfway through being updated by the database process. At the other end, we've got the AWR repository. Now that is a set of database tables, and it's populated by a process, and it's just a table like any other application table. And it contains the automatic workload repository data, which includes active session history. So, when ASH was implemented, they architected an in-memory buffer. And they talk about this as being a circular buffer, and it was sized at 2 megabytes of memory per CPU. And they introduced a new process, M1 Lite. And the job of M1 Lite is to read that session state object and write it into the circular buffer. And it just goes round the circular buffer, round and round, until it overwrites what's there before. Like that. And the writer goes one direction, and the readers go the other direction. Oh, these ASH records are on variable length as well. And that ASH buffer is exposed as $V active session history. So when you query the ASH data in $V active session history, you are querying this in-memory buffer directly. And this is the 1 second sample. Every second a row gets written in here. And the readers, and querying this $V view as a reader, goes the other way. So you always get the most recent ASH data first in your queries on $V active session history. And these readers are unlatched, so they don't block any of the other processes. This view is indexed on time. basically in descending order of time, the sample time. The AWR snapshot process, which we're probably all quite familiar with anyway, it, amongst other things, it pulls 1 in 10 samples. So a sample in this case is the set of samples that happens at each point in time. So every 10th sample, which is every 10 seconds apart, it will be pulled from this buffer and written to the AWR repository during an AWR snapshot, or if this buffer fills up, you'll get an emergency flush to the AWR repository. And that's how your data gets to DBA HIST active sesh history. And this process was designed to be light and simple and not get in the way of doing your processing. And then finally, your AWR data is exposed through this view. Now I have to just say, ASH is a licensed product. It's part of the diagnostics pack. It costs money. It's how it is. Graham used to tell a story that Larry Ellison could remember the last time he'd said no to making it freely available. So this isn't likely to change. It's only available on Enterprise Edition, and the cost from the price list is about 16% of your basic license. It's quite often sold diagnostics and tuning packed together. Tuning is, I think, another $5,000 per processor on top of that. So yes, it costs money. Now, I don't work for Oracle, and I don't get commission for saying this, but I think it's well worth it, because if you don't have this, as you'll see, you're going to be blind with what's going on in your application. It's very much harder to do performance tuning without active session history. So I think this stuff really does have a value. What if you're not licensed? What if you're back on standard edition? You can't even pay for ASH on standard edition. Well, conceptually, ASH is just about sampling and storing the content of the dollar session, and a few bits more nowadays. There was an open source project started by Carl Haley and now maintained by Marcin Prishparovsky, which is an open source SQL-based product which just pulls the data out of the $X KSU's table. It's all written in PL SQL, and it runs from the database scheduler, and it pulls the data into another storage database, and that's done to minimize measurement intrusion effect. And pretty much it's the same as ASH in version 10G of the database. And I've compared real and simulated ASH on Exadata, and it's pretty close. It's good enough for all practical purposes. What I will say is that any of the stuff that's been added to ASH in 11G and later, that hasn't been exposed in that $X view. So SASH can't store that data. So a lot of the things that have appeared, you can't do with SASH. But this is an open source free alternative. It's something to investigate if you need to. So, as I've said, ASH is sampling. It's about approximation. It's about working statistically. The next stage is you start to categorize your ASH samples into different subcategories. And you can start to tell different things about the ASH data and determine what's going on. The key thing with ASH is that you can simply query it in ordinary SQL in order to find out what's going on. And you start to write SQL of this form. So you select, if it's recent data you're after, it happened inside the last hour, the 2 megabytes per CPU, the idea was you'd have about an hour of data in a database. Sometimes you have much more. It's frequency test databases with 10, 15 hours of ASH data. It's not uncommon. Sometimes you see very active databases where the top activity chart in Enterprise Manager doesn't quite reach all the way to the y-axis on the left. And that's because some of the data has been overwritten in less than the hour. But if it's recent, You look at $V active session history, you count 1 second per row, so it's sum 1, where it's the rows I'm interested in, and that depends on your question, grouped by the thing I want to profile by. What are the top thing I'm interested in? Might be SQL ID, might be plan hash value, might be something else. And then order it by the amount of time accumulated in descending order, so that you have a profile with the thing at the top that burned the most time. And of course, if you're doing that on historical data, then you write pretty much exactly the same query on DBA hist active session history, but you count 10 seconds per row. And after a while, all of the SQL you write tends to look almost identical. This is a hugely powerful concept if all you've been used to up till then is using trace. I think when I first saw it, I had to watch Graham's presentation twice before I understood the significance of what this was. I could now just proactively query performance data, and I didn't have to set up trace. And I could ask questions that users hadn't yet asked. Little aside, there's a new column in ASH in 12.2 called USEX per row, microseconds since the last ASH sample. It's not documented till 21C. And if you did that, use that instead of 1 and 10 and then divided by 1,000,000, you'd actually be writing exactly the same data on recent and historical data. So something new to do. Most of the examples you'll see today still use 1 and 10 because they've been curated from real life before that column was introduced. Probably worth just standing back for a second and just talking about the difference of approach between ASH and the trace technologies, particularly Oracle SQL Trace. So I probably spent the first 15 years of my career tracing everything inside, and I've spent the last 15 years using ASH and only very occasionally going back to trace. So ASH is licensed, and that's how it is. And SQL Trace is free, and it always has been, and it's been there since Oracle 6. ASH is always there, though. There's no marginal cost for switching it on. Trace has got a runtime overhead, and that overhead varies depending on the nature of the program and the level of trace you're collecting. If you want to collect SQL and binds, and you've got a database that does a lot of parse, because it's that kind of application, trace will have a bigger overhead. You also have to enable trace, collect files, and profile them. And that involves work. And there are tools out there that you can look at that will help you with that. But you've got to do that work, and you may have to wade through a lot of trace files, depending on the application. And of course, you can imagine the situation where a user phones up and says, look, my application was slow. And you say, okay, well, tell you what, we'll turn on trace for your application, and then could you go through all that pain of poor performance again, and then we might be able to work out what happened. It's not a good support conversation. It wasn't a good support conversation 15 years ago, and you certainly wouldn't get away with it today. ASH allows you to be proactive and perhaps even look at the performance problem before the user has phoned you up. So you can be proactive and you can do it in real time. And unless you've turned on trace, trace is going to be, you will always be reactive with trace. Bear in mind though that ASH is statistical. Not everything that happens is going to be caught by ASH. If it doesn't last a second, it might not get caught. Whereas trace really is every SQL, every database call. And so if you've got a short-lived, reproducible problem, then you might want to investigate that by tracing it. And that's something you might very well do. The other thing is, trace will tell you that you are being blocked because you're waiting on, say, a TX row lock event. ASH will tell you who is blocking you. and then you can go and see what they're doing while you are being blocked. There's an example of that coming later. You will get the actual SQL and execution plan if there's been a pass in the trace file. With ASH, you're dependent upon AWR having collected the SQL and the plan. And sometimes it does, and sometimes it doesn't. So you will get an exact duration for every activity and for each line in the execution plan in the trace file. But really, you're only going to have an estimate of the duration of each statement and each operation with ASH. So there are differences. I think most of the time ASH is good enough for all practical purposes. I very rarely now need to reach for trace. Sometimes I do. Most of the problems I can diagnose with ASH. It's that good. It's rare now for me to use trace. But you may have to reach for it occasionally. Okay, pause for a second, see if there are any questions. No? Yeah, you're welcome during this to ask questions. You have to do it through the question window. And I'll pause a couple more times and we'll look at them as we go. So, think of ASH as a data warehouse of performance metrics. It's a very big fact table. Each row of ASH data is a fact that there was 1 or 10 seconds of database time. And then that fact has got various dimensions and attributes. And there are 6 broad areas. You've got session information, session ID, serial, instance, if you're on rack. The query coordinator, session ID and serial, if it was if you're dealing with a parallel query server process. Information about the container if you're on a multi-tenant database, and you've got these in flags which tells you what's the state of the SQL. Was it in parse, in execute, was it looking at bind variables, and so on. So you can kind of see what's going on. You get information about the wait event, class, event, the event parameters, which might be useful. It might be a file and block. And you get the information about the blocking session if you were blocked by another session, even since 11G R2 on another rack instance. Information about the application, the program name, the machine, the port it's connected to. Probably the 2 most important things, module and action, which we'll talk about in detail in a minute, which are strings which hold information put there by the program. It gives you context information. You might get a client ID, and you also get this ECID, the execution context ID, which is mainly used for tying a database session back to say a Java thread. You get lots of information about the SQL, the opcode, the plan hash value, what line in the execution plan was being executed, the top level SQL ID if it was PL SQL, the full plan hash value if it was an adaptive plan, so you can tell if you've got 2 plans within an adaptive plan. You get an execution ID, so you've got an idea that different samples were different executions within the same session. You can see if it's running a database transaction at the point in time. And you get information about PGA and temp usage. Lots of information, and it's got more information that's been accumulated there with later versions of the Oracle database. So Oracle continue to invest in active session history. And the final thing, you get information about the object you're being working on. So if this is only valid if you are doing a physical I/O. So if I'm, say, doing a DB file sequential read, I get the object, file, block, and row number within that block that is being read by this operation. And I can start to track that back. Beware that this is not valid if you're not doing a physical I/O operation. So you need to see file and block as a parameter type to the wait event. Otherwise, it's just left over from the last person who did that. So all of this ASH data accumulates over time in the AWR repository, and various things pull it back. There are AWR and ASH reports. There's Enterprise Manager and Enterprise Manager Express. This is Express from 19, and I've got some activity here, and I can choose my time window. I can look at active sessions by graphed by attribute, so what kind of wait event. The colors are different to Enterprise Manager, but you can see the wait events up here on the right. I can control, I get tooltips if I wave my mouse over it. I can control how I profile the attribute. So here I've got a profile by force matching signature, and I can see which signatures are the ones which burnt the most time. And here I've got module and action. So I can see which modules and actions are at the top. And this application is partly instrumented because I've got some names here which mean something within the application. Turns up in AWR and ASH reports. Lots of the numbers here actually are derived from ASH. Some of them are derived from system statistics. So if you do your report for a pair of snapshots, and then here I've got ASH data, I've got phases of execution, I've got what kind of statements, I've got service and module, so I've got my different module names again that were put in the application. And here I'm looking at the amount of time on what kind of row source operation in the plans captured by AWR. You can run ASH reports from Enterprise Manager, and here's an older version, but I'm going to filter it by a particular module that I'm interested in. Happens to be a payroll calculation. And I can see information about that. So ASH tells me that I'm looking at 86% of the database activity. I've got 14.8 active sessions out of my 32 processes. I can see the top SQL, but I'm not going to get execution plans in my ASH reports. This is one of the reasons that I tend to move from ASH reports to digging into the data directly. Now this database, this data warehouse of performance metrics, it's really valuable. You really need to be keeping it. Common online to keep it for, people keep ASH data for different amounts of time, certainly 7 days. In a lot of financial systems, people keep it for 6 weeks, 42 days, so that you might have a 5-week month in sub-accounting systems. And you want to look at this month end versus last month end. So you need 5 weeks plus another week. Some people copy it back to a central repository. Again, maybe some people talk about 400 days of ASH data in your central repository rather than in your live database. And that's a year and a month and a week. If you're a retailer, you might want to look at this Easter versus last Easter. Easter moves around. So sometimes it can be nearly 400 days between Easters. I've seen people roll their own and copy it around using AWR extract and load. And I've seen people do it with Enterprise Manager. Unfortunately, I've not seen it done very often because it's really valuable to have this consolidated data. One of the examples is that you might want to look at common artifacts in the data between different databases. I found a SAN performance problem once because I saw the same slowdown in physical I/O on 2 databases that shared the same SAN at the same time, but they were otherwise on different hosts. I'd never have found that without the consolidated view. 3 most important things probably are instrumentation. The most important thing a developer can do is instrument their code so that it turns up in active session history and the AWR reports and a few other places as well inside the database. And it gives you the ability to match your database sessions to the application processes. It gives your SQL application context. You know, how often have you pulled, as a DBA, have you pulled a SQL statement out of the database, gone round to the developer and said, look, this SQL statement where does it come from? And the developer looks at it and says, I don't know, never seen it before. I've certainly had that experience myself. So Oracle gave us DBMS application info as far back as Oracle 7.3.3, and it sets these two session attributes, module and action. They're just strings, and you set them to whatever you like, so long as you're consistent and it means something to you. And those session values get picked up in ASH and AWR. You can see it in session trace. You can see it in some of the plan stability views. And it's hugely valuable. Not all applications are instrumented, and it can be really problematic when they're not. Few packaged application vendors do put it in. Oracle eBusiness Suite is instrumented in particular, and nowadays PeopleSoft is instrumented. When I'm writing PL SQL, and I'm quite a primitive PL SQL programmer really, this is the kind of thing I do. I'll have my package name in a module, and $PL SQL unit is my package name. And then in every procedure, I'll have a couple of local variables, and I'll store off the current value of module and action. And then I'll set my module and action. So in this case, I'm going to set it to my procedure, and module is my procedure name, package name, sorry. Then I'll do my package, whatever it is. And then at the end, I'll restore the saved value of module and action that I recorded at the top of my procedure. And I must also do that at every exit point and every exception. Now I can look at my module and action data, and I will get a profile of how much time I spent in which module, in which action. And if I have a performance problem, I can identify which piece of code it is. Then sometimes during a PL SQL procedure, I might put other data into action as I go. Might be my procedure.123, or I might put a value in there so that I can pull that data out of ASH and process it. And nowadays you've got 64 characters for module and action, so you can store quite a bit in there. Entirely up to you what you do with it, but just be consistent. And this is something that developers need to be encouraged to put in. It's like debug code, and it's massively valuable when you're dealing with system performance tuning. Now, sometimes the developers may not do it for you, and you may need to be creative. We have this, for example, in PeopleSoft. Their AWR and COBOL programs are not instrumented. They don't call DBMS application info. But the first thing the PeopleSoft batch process does after it's been initiated by the process scheduler is it sets its own status to processing. And it might set a couple of other statuses as well. So if I put a trigger on that status change, I can set the module in action inside the session of that batch process. And that's what this trigger does. And I wrote my own little PL SQL API to do a few things and set the API and set module in action. And that's how I instrument PeopleSoft processes that are not otherwise instrumented. And it tells me what is the process name and the instance number, so I can relate it back to something in the application. And this is one of, I think, the exception that proves the rule. It's one place where I do use exception when others they're null, because if something goes wrong here, I don't want it to crash the PeopleSoft process scheduler. I don't care if this raises an error, as long as it does no harm. So maybe this is the one occasion where you can do this. And this is an example of do-it-yourself instrumentation that has a DBA you can put in. Now, of course, if you haven't been instrumented your application, what you get is this. You do your profile and then you realize, yeah, 97.8% was JDBC thin client. At this point, a profile of DB time by module is completely useless. It tells you nothing about the database, and the other entries here are actually Oracle's database stats processes, a couple of other things. So this is what you see in a non-instrumented application. What you'd like to see, of course, when you profile it, is something like this. Again, this came off a PeopleSoft system. Okay, 35% was others. We're only seeing about the top 14 issues here. We've got a streams processor coming in. And the third one, 8.7%, was on, it's the component in PeopleSoft HR that maintains an employee name. That's what HHER name means. So I can find the SQL and know that it came from this part of the application, and we can look at why this part of the application is consuming 8.7% of my total database time. This is why you do instrumentation. It's massively valuable. And if I pull the SQL out that was responsible for that 8.7%, I can actually know, I will know that it came from that particular component. And I can have a far more meaningful conversation with the developer, perhaps whoever it was who customized the component. Okay. Right, still no questions. Better keep going. So, mining the ASH data. This is what it's really about, writing your own queries. Have a clear idea of the question you're asking in plain English, I would say. So what are you interested in? What time window am I interested in? Is it recent? Is it historical? Was it the batch program that ran from 3 till 5 this morning? That kind of thing. Am I after one session? Can I identify that session? Was this a group of sessions? Or do I just want to add up the whole database? It's that kind of thing. What sessions am I interested in? Do I want all the ASH data? Or am I only interested in maybe one particular event? Or maybe I know the SQL ID and I want to know when it ran. Or maybe it's one execution plan. If I'm going to look into database locking, I'm going to have to relate ASH data to other ASH data. So let me show you an example. Profiling database time by different attributes. So here's an example. So I might profile by SQL ID or by force matching signature. Plan hash values are popular. Event weight, event class, and the event, and the status. So there's lots of different attributes you might choose. Now, when you query these ASH tables, and I'm now going to tend to focus on the AWR repository. DBA HIST active session history is a view of WRH dollar active session history. That table is partitioned by DBID and SnapID. So to efficiently query it, you need a query predicate on these two columns. So I tend to join in DBA HIST snapshot. And that's how I relate a time window to the DBID and SnapID. So I start to build queries that look like this. I'm going to join the two views together on Snap, DBID, and Instance. And you tend to need a hint to force it to start with the snapshot. And then I'm going to have two pairs of time predicates. I'm going to look for snapshots that overlap the period of which I'm interested in, 7:30 in the morning to 8:30 in the morning on the 1st of February. That gives me a rough match of snap IDs. And then I get an exact match of sample times. And then I'm going to look for a particular module name, PS app serve. This process wasn't instrumented, they turned instrumentation off, so it's just the program name. What do I get? I get a list of SQL IDs and plan hash values and the amount of database time that each one took. And the one at the top took 1360 seconds. That's the one I should start with, and I'll work down that list looking at them. And I start with the one with the most time because I've got the most time to get back and I've got the most chance of removing time from it. But that's all the information I get from ASH, a SQL ID and a plan hash value. If I want to know more, I've got to go to AWR. So then you have to extract the plan from the AWR with DBMSX plan, display AWR. And you end up copying the SQL ID and plan hash value in here. And if it's recent data and you want to get it from the SGA, you do pretty much the same thing with display cursor, SQL ID, and cursor number. Now I'm very lazy and I get bored easily copying this stuff around, so I tend to write SQL to generate the commands to do the selects. I write dynamic code. And this kind of query will generate the queries I have to run to get the execution plans. And it's a lot better than cutting and pasting this stuff around. The next question is, which part of the execution plan should I focus on? And sometimes you look at an execution plan, it's not obvious where the time was spent. Remember that most of the numbers, the costs and the time, estimated times, they're coming from the optimizer. And if you've got a performance problem, there's a good chance that reality has parted company with the estimates from the optimizer. It's made a misestimate for some reason. So this is a way of saying, how much time did I actually spend on each line? So which line spent the most time and which part of the plan should I focus on? So I group by SQL plan line ID. And now it's very obvious which two lines in my execution plan spent the most time. And that's the area I should focus on. So lines 24 and 25, here's my plan. It's these two lines. Whatever it is that's going on here, this took me the most time. Why? Doesn't matter for today's presentation. Now you're into analyzing SQL and you've got to look at the execution plan. But ASH will lead you to the place where you need to dig further. Sometimes you might also profile by the event. So here, line 3 took the most time. It's this table access by row ID. I did a single block lookup, spent lots of time on DB file sequential read. I also spent some time on read by other session. So not only am I doing a lot of read, other people are also doing a lot of read. I have a hot block problem and I'm waiting for somebody else's read to complete. So it tells you a little bit more about what kind of events going on and what I might do about it. Okay. Bind variables. Very simply, developers should use bind variables. It's a little more complex than that, but quite often they don't. And what happens when you're dealing with SQL that doesn't use bind variables, it uses literals? It does make your life more difficult when you profile the ASH. So here I have different, this is again a real profile taken from real life. Here I have different processes and the top SQL statements are all different. Very few of the SQL IDs are in common, but I've got 2 or 3 execution plans. So these 3 statements have the same execution plan, and then I've got a few other execution plans. Again, the SQL IDs are all different. So what's probably going on is that I've got a different literal value in there. It's enough to make the SQL ID different. And the kind of thing you see in code might be like this. This came from a PeopleSoft Time and Labor badge. It's a security query. And what it's done is it's grafted the operator ID on as a literal value instead of using a bind variable. Not a great thing to do because now every SQL statement is different. So when I profile this process, I've got lots of SQL IDs, which all took a little bit of time. I don't really, from this profile, get a feel for what was the thing that spent the most time. So if SQL statements are similar enough to exhibit the same SQL plan hash value, they've probably got the same problems and can be addressed by the same solutions. So what I tend to do is profile by plan hash value. If I do that, it's now completely obvious what my problem is. It's all about that plan hash value, and I should focus on that. The question now is, can I get the detail out of AWR? Because if I got lots of little SQL statements, it may not get picked up by the AWR repository. It might have been aged out by the time the snapshot went off. It might not be significant enough to be picked up by the top end queries. So, can I find the SQL in AWR? I get my ASH data and I join back to DBA his SQL text by SQL ID. I outer join to see whether I can find that SQL ID for any of my plan hash values. And I've got my sum 10 counting database time for all of my ASH data, but also I'm going to count what I call AWR seconds. This is database time for which I know the SQL statement. If I can find a T-SQL ID, if it's not null. And then I can use a bit of an analytic function, and I can say, for each SQL state, each plan hash value, which SQL ID consumed the most time. And I get a profile like this. I get a profile by plan hash value, and now this is the SQL ID which burnt the most time. And if I've got AWR seconds, I know I've got a SQL statement that I can look up in AWR. Now, this one's a special case. Plan hash value 0 occurs for insert values, and it occurs for PL SQL. This happens to be DBMS stats. So there were 74 different SQL statements that collected stats during this in this process. That's a special case. This is what you hope to see if the developers use bind variables. I get one SQL statement, and that's the ID and the plan, and it was all captured. Here, I've got 198 different SQL IDs that all exhibited this plan hash value, and this SQL ID is the one that burnt the most time. Rather unusually, they were all captured by AWR. That doesn't always happen. Sometimes none of them are captured, and it's really hard work. So I can look at one of these SQL statements and try and work on it. And it just leads me to the thing that I should be focusing on. Okay, keep going. Probably the last topic for today, lock analysis with Ash. Where did we wait on a lock? Pretty straightforward query. I'm going to look for event is NQTX, row lock contention, and I'll get all of the SQL that was blocked. Great, so I've got some SQL IDs and plan hash values. I've got lots of time. Let's go and have a look. And what I get is this. This is actually from PeopleSoft. You see this a lot with PeopleSoft, actually. These are homemade sequences and lock managers. They are deliberately serializing processing by updating a value on this table. These queries are all keyed by primary key. You're not going to make these any better. The question is not why are these statements slow? The question is who was blocking them and what were they doing while they were holding the lock? And can I do something about that? This is also an example of why you should be using database sequences and not building your own homemade ones, but that's another story. So you want to resolve the lock chain. I've got 3 sessions. So session A is blocked by session B, and session B is blocked by session C. But really, session A is blocked ultimately by session C. So what I do is I update the lock chain on session A to say that actually it's blocked by session C. And I do that in my own temporary table by navigating this lock chain. And again, since 11G, it works across rack instances. Although you have to be a little bit careful, though you may find there will not be an ultimate blocking session because the session isn't active. It could be that what is blocking the database is a client session that's waiting for something outside the database. It's idle on the database. And that's very frequently a problem. To extract the hash into a data, and I will repeatedly update the data, updating the lock chains. And then, once I've done all that, I can just join the data back to itself by the locking information, where the waiting event is TX, and I can get a profile of what the holding sessions are doing. There's a document on my website which has got all the code for doing this. And if I'm doing it cross-instance, I have to be a little careful because the timestamps on the Ash events may be different on different rack instances. So they're only going to be accurate to within 5 seconds. Plus minus 5 because it's a 10-second interval. And I can find the same profile blocking, find the blocking instance. And that will give me an idea of what's going on. So in this case, I've found 4 blocking segments, and notice that top row, it's idle. Whatever's holding the lock is outside the database. And once you see that, you've got to find out what the application is doing and why is it doing it, because as a DBA, you can't answer it. And it may be that you get the same SQL statement because it's self-locking, and it may be that you find something that's just genuinely a SQL problem and that you can tune out. But now you get a feel for what the blocking session is doing. There is a plan cost trap that you can fall into, and I fell into it when I first found this. So I found this statement, and this statement was one of the things that was running while in the holding session. And it was doing a file operation. And I looked at it and thought, well, the cost isn't very high. Why is that such a pain? And then I did it, only got a cost of 22. Note the cost, the plan, and the bind variable value. Then I did explain plan for to generate a fresh plan, and I suddenly got a very different cost. Be aware that the costs in AWR are the costs at the point in time when the plan was captured. And if I keep seeing the same plan over time and the costs progressively increase, AWR will not update those costs. So it can mislead you. There's a couple of blogs to read on that. There's lots of other uses of ASH out there. There's another whole presentation I do on this subject. You can detect plan stability and did the plan change? Did I get adaptive plans? I can analyze physical I/O. What are my hot tables and indexes? Which process is doing it? You can sort of get a feel for whether an index is being used. It's not perfect, but you can. You can investigate temporary table space usage and PGA usage to see which processes are consuming the most PGA and to get an estimate of how much PGA the database really needs. You can investigate parallelism. You can see whether your use of parallel query is effective. Are you firing up lots of parallel query sessions and they're not really getting a lot of database time out of them because it wasn't an effective use of parallelism? Consolidated data is quite interesting. You can export and import AWR data and the ASH data with it, so you can see which database is active within that consolidation. If you've got container database, then you can see, without any of that, you can actually see which PDB in your database is the most active. If you connect to the container database, you can look at all of the tenants within your multi-tenant. So there's always more you can do with ASH. Mostly it's a matter of imagination to see what you can dig in with. The more familiar you become with this by using it, by querying the data yourself, I think the more comfortable you'll get with using it. Okay, so I really have reached the end. I hope it's been useful. There's lots of stuff about ASH on my website. There's a second presentation. There is a paper out there called Practical ASH, which has got the examples and some of the scripts. There is no substitute for working with the scripts yourself. You can't do any damage. All you can do is create a long-running query. But go out there and explore. If anyone wants to ask questions, I think we may have a few minutes. I think it has to be done by text. Otherwise, we can do it by email.
Thanks so much, David. It does look like there are a few questions in the questions box. Are you able to see those? Amit Saroha asked, do we need to include something before leaving a module for DBMS_application? Because sometimes it gives the wrong result.
When you leave an app, if you looked at my example, I stored the module and in action when I came into the module, and then I set it at the top of the module, and I stored them in local variables in each procedure. And when I leave the procedure, I reset the value that I stored at the beginning. So that when you leave the procedure and return back to the parent that called it, I have the module in action set that was previously set in the parent. So it's like a stack. I've created a stack of procedure calls, and I've got local variables for each of those procedures in the stack. And some of those local variables include the module in action. And as I close a program, it comes off the stack, and I reinstate the module in action that was there before. Oracle doesn't do this for you because it doesn't know where the procedure beginnings and ends are. So it's your responsibility to set and reset DBMS application as you move through, say, a PL SQL program. If you're in, say, an online application, and again, I'm going to use PeopleSoft as an example, it simply sets the module in action to the component and page as the user navigates. And there's no need to have this sort of stack approach. Some batches, they just set it at the beginning and never reset it. It depends how granular you want to make this instrumentation. But that's why, if you're not resetting the original value, that's why you're probably getting the wrong result. Is SQL generated by a JDBC connection captured in ASH? Yes. Basically, if a session is active on the database, it will be collected by ASH. So if you're waiting on an idle event, it's not active and it won't be captured. The one little thing you can get caught out by is that if you're waiting on a database link and the remote database is active, your session is not active, therefore you won't get ASH data, even though the SQL statement is really active in the perspective of the user, and that can actually mislead. Is it advised to run global ASH report or run specific on one instance? The ASH data is in the AWR repository. It's part of the database. So there's not a problem running it cross-instance. And if your application is cross-instance, you should run it for the whole database, and it doesn't really matter where you run it from. Some data in AWR comes from ASH. Some comes from system stats. Some comes from the OS stats. There's a lot more in AWR than just ASH. ASH is just one more group of data that's been shoehorned into AWR. I mean, it was an entirely logical place to put ASH because you needed to refer back to the captured SQL. But if you look at tools like EDB360, that harvests all of the AWR data and some of the dynamic performance views. And you can see where all the sources of data are. And you can also look at the SQL that was used to generate the queries. So you can understand what the data means. I think that tool's quite a useful thing for understanding where the data originates from in AWR, so you can start to join it together. I think a lot of the ADDM comes from other sources of data than just ASH. And I think I've answered all of the questions.
Perfect.
So I'm going to say thank you all for joining me, and I hope it's been useful. And if not, if you've got other questions that you think of, feel free to reach out to me.
Thanks, David. Well, if there are no other additional questions for David, we'll go ahead and conclude today's webinar. Again, thanks everyone so much for joining us this afternoon. Coleman, it's always a pleasure. Thank you so much, and NYOUG for your partnership. And I hope everyone has a great rest of your week, and we will see you next time. Thanks, guys.
Thank you, Katie. Thank you, David.